let's have a quick look back at system of linear equations. You remember that we had this, right? So we had, if you have y equal to alpha times x plus beta, and if we have x and y being 1 and 1, 2 and 1.5, then we can estimate alpha and beta, right? We can devise a system of linear equations from this, right? We plug in x and y, and then we'll have two equations, and then we'll estimate alpha and beta using a backslash b, right? Do you remember a and b? Let me just put the dots first, and then we'll talk about it. So 1 and 1, 2 and 1.5. I can feel a line that goes through them, right? This is mine. Perfect. And then we discussed this before, but just to jog your memory, if I plug in 1, I should get 1. So 1, y equal to 1, alpha times 1 plus beta. And if I plug 2, I'll get a 1.5. So 1.5 is alpha times 1.5 plus beta. And then the coefficients of the unknowns will be in matrix A. So matrix A would be 1, 1, 1.5, and 1. And vector B is the right-hand side, which is the known side. In this case, it's on the left. So B is going to be 1 and 1.5. A backslash B will give me alpha and beta. Do you remember this? Some students look at the board like they've never seen this. Yes?
Shouldn't alpha, the same equation should be alpha times 2, if not alpha.
Absolutely. Alpha times 2. So does this familiar now? Awesome. So how many elements will I get from A backslash B? I got 2 elements. What is the first one? Alpha. What's the second one? Beta. Right? So this is the coefficients of alpha, and this is the coefficients of beta. We also discussed that we don't really have to write the equations to have matrix A. Do you remember what we discussed? How to create matrix A without writing equations? We can use the equation itself, the original equation. The first column is the coefficients for alpha. What is the coefficient for alpha? X. What's the coefficient for beta? 1. Right? So I can write A as being x and 1s of lengths of x, comma 1. The coefficient for alpha is x. The coefficient for beta is 1. Right? How many 1s do I have here? I have 2 1s, right? It's a column vector. I have 2 1s in my column vector. So I have 1s of lengths of x. What's the length of x here? I have 2 elements in x. 1s of 2, 1 is 1 and 1. That's a column vector. So ones of length of x comma 1 will be the last column. Does that make sense to everyone? Is that clear? Nicole? Which part? So let's look at this one. What is your first column? Is your x values, right?
Yeah.
1 and 2. So that's your x values.
So what was that? What I was tripped up on was, so say you were going to plot A that way. Obviously, you need to define X.
You need to define x first. And x should be a column vector. If x is not a column vector, you need a prime here.
Okay.
And y also should be a column vector. So if you say b is equal to y, this y should be a column vector. If not, you need a prime. You need to transpose them into a column vector. The reason this last one, we need all ones, right? So we have a column, we have one for each element, right? How many elements do we have? Same number as x. If you have two x values, we need two 1 values. That's why you have ones of lengths of x comma 1. If it helps, that could be ones of 2 comma 1, because length of x is 2 anyway. Is this more or less clear? All right. So I'll erase this, and we can move to curve fitting now. Let's say we don't have 2 points, we have 3 points now. The third point being 3 and 3. How many points do I have on this line? Infinite. Infinite number of points I can have on that line, right? Let's say I want to fit this line, alpha times x plus beta, to 3 points. Let me put the third point also here. So, do you think I can find one line that goes through all of those points? No. Because third point is not on the line that we fitted to the first two. What do I do now? If I want to fit a curve, or if I want to fit a line to these points, I know that the line will not go through them. But I can find a line that is closest to all of them, right? I can find a line that doesn't go through them, but it goes in between them. I can do that, right? In order to fit this line to these 3 points, what we need to make sure is that we minimize the difference between what the line gives us and what the observation point is, right? So at x equal to 1, the line gives us some value, right? At x equal 2, line gives us some value. At x equal 3, this line gives us some value. There is a difference between what the line gives us and what the observation was. We cannot find a line that goes through them. So there is, in the previous case, what was the difference between what line predicts and what was observed? What was the difference between them? 0. Went right through them. So the difference was 0. But in this case, there is some difference between what the line gives us and what the observation. This is called observation. This is given to you. This is what's observed, and you're trying to fit line through this data. There's a difference. What you try to do is you try to minimize the difference between these points, the blue points given, and the points that the line gives us. Does it make sense so far? So we can have all sorts of lines here. We can have this line, we can have this line, we can have, of course, the first line, we can have, I don't know, this line. There are so many different combination of lines based on alpha and beta, right? You want to find alpha and beta that minimizes the difference between what the curve or what the line gives us and what was the observed points. But how to do that? Are we using the summation of the differences? Because we have three points, right? 3 points, we will have 3 differences, right? In this case, I have this minus this, let's say 0.3. And then I have this minus this, that's negative 0.1. And then I have this minus this, that's a 0.1. Right? I have 3 values, 0.2, negative 0.1, and 0.1. How do I minimize 3 values? If I have one value, I say like, I want that one value to be 0. But when I have 3 values, you make one smaller, the other one goes bigger. We have to dump all those information into one value. So rather than having 0.2, negative 0.1, and 0.1, we need one value. How to dump all those information, or how to aggregate all those information into one.
Sum the absolute value of each one.
I like your idea. I was gonna start with sum of all of them, but what would happen if I take the sum of all of them, not the absolute value?
If you have negative values, it's not going to take the total distances between them.
Exactly. So see, because 2 of them are positive, 1 is negative, if I take the sum of all elements, that might go to 0. A negative distance and a positive distance, we don't really care, that's a distance, right? Absolute values are important for us. So we can use sum of absolute values of differences between what was predicted and what was given. If I ask you what is the predicted value, is it the one that line gives us, or is it the one that x and y that was there? A line. So the predicted value is the line. Should it always be a line?
Yes.
In this case, yes. But it depends on the problem. You might have a curve, you might have a line, you might have different things. Your model could be different, right? So prediction is what comes out of the model. Observation is what is given to you. We want to minimize the difference between prediction and observation. One way to minimize that is to minimize, so residual is, this difference is called residual. Residual is y minus y pred. The difference between y observation and y pred is residual. Does it matter if it is y pred minus y or y minus y pred? Doesn't matter, because we need to take the absolute value. One way to fit that line is to minimize sum of absolute value of residuals. That's one way to do. The other way that is widely used is to minimize sum of residual values to the power of 2. If you raise them to the power of 2, everything is going to be positive. There are reasons why this is a better choice than this. I'm not going to go into details of that, but there are several advantages for this over this, and of course there are some disadvantages as well. But what is used is basically minimum of sum of all residuals squared. Is it clear so far? So we need to find alpha and beta. So we start with some alpha and beta, and we keep changing alpha and beta. For each alpha and beta, we'll have 1 by Pareto, right? For each alpha and beta, we'll have 1 by Pareto. I mean, a series, I mean, a vector of 3 by Paretos. So you can change alpha and beta so many times until this is minimized. So sum of residuals squared is minimized. Does it make sense so far? How do we do that? How do I find alpha and beta now? I know that at the end of the day, I want to minimize sum of residuals, so I need to change alpha and beta values until this is minimized. But how to do that? Again, there are so many different ways to do this. But that A backslash B not only fits a linear system of equation, if needed, it will find those alpha and beta and minimizes the residuals. So similar to the previous approach that we had for linear system of equations, we can use the same thing here. We can create A x prime is the first column of A, which is associated with the unknown alpha, and ones of lengths of x comma 1 is the coefficient of beta, and B is basically y prime. If I do A backslash B now, that will give me alpha and beta for which sum of squared residuals is minimum. Let me solve this very quickly for you, and let's see how it works. I will first start with the first 2 points that we fitted a line through. So x was 1 and 2. Y was 1 and 1.5. Is the font all right, or do I increase it? It's fine? Okay. So I had x and y before. I created my matrix A was x prime. Why do you use prime? Because x is horizontal now, I want it vertical. And lengths of x, or ones of lengths of x, comma 1. That's my A, which, if you remember, we had 1 and 2 and then 1 and 1 in the previous example that we had. B is equal to y prime, which is 1 and 1.5. My unknowns are basically a backslash b. So I have alpha equal to 0.5, beta equal to 0.5. Right? Alpha equal to 0.5, beta is equal to 0.5. This is for the previous example that we had, for x and y, each of them 2 values. Right? Now that I have alpha and beta, and I have this equation, I can plot this line, right? With alpha and beta, I can plot this line. Let me first do this. Plot x comma y comma red asterisk, and then I'll change my marker size. I want it to be big, to be 20. And let me also change my axis so you can see the values. It goes from -1 to 10 and from -1 to 10. Well, it looks like 10 is too big. What's that? So I've observed these 2 points, right? 1 and 1, 2 and 1.5. These are my 2 points. And I feed a line through those 2 points. I have 0.5 as alpha or slope, and I have 0.5 as beta, which is intercept, right? Now I want to plot a line with alpha and beta that I have. In order to plot a line, I need some x values. How do I create those x values? Linspace. So xx is equal to linspace. I want to go between -1 and 5. And yy is equal to what? What's the y values associated with those x values when I want to plot my line? What is my function? What is my function? 0.5x and plus 0.5, right? 0.5x plus 0.5. My x is xx in this case, so I have 0.5 times xx plus 0.5. Does it make sense so far? And then I had my plot. I'll do hold on, and then plot xx comma yy. So what I have now is I have a line that went through the 2 points that I had. That was the first problem. We solved it. There is an absolute answer. What is the residual between the two? What is the residual between prediction and observation? 0. The line is going through all the points. So the difference between the line and the points is 0 and 0. So sum of the squared residuals is sum of 0 squared plus 0 squared. How do I know that? So this is my line. I calculated alpha to be 0.5. I calculated beta to be 0.5. Right? Residual is my line minus my y. All right, let me do this. CLC. Residual is whatever my line was minus my y. And I'll get to that. So I have a y of 1, I have a y of 1.5, right? Then I want to find what my line gives me if x was 1, what my line gives me if my x was 2. So that's basically my line, which was 0.5 times x plus 0.5. Why do I use x here? Because at x equal to 1, y was 1. We need to know at x equal to 1 what line gives me. At x equal to 2, y was 1.5. I need to know at x equal to 2 what this line gives me. Does it make sense so far? Danny, you're with me? Awesome. So if I do this, I'll get a 0 and 0. That was what we expected already. That's the difference between the line and the given point. The difference between the line and the given point is calculated for y, right? X is given, y is obtained. So what is obtained from the curve or from the line minus what was given as y is the residual. Is it clear so far? Now we change our x and y values, right? So we had previously we had 1 and 2. Now we have 1, 2, and 3. So let me add 3 to my x values, and my y is, it used to be 1 and 1.5, it's now 1, 1.5, and 3. So if I now plot x comma y with a red star, red asterisk, what you see here is that my previous line doesn't go through the third point, which was already discussed. Now, using the new method, we want to fit a line that goes in between these 3 points. Now I need to redo my A and B matrices. The formula doesn't change. It's the x values that changed. So x prime and ones of lengths of x comma 1. Still I'm looking for alpha and beta. Coefficient for alpha is x, coefficient for beta is 1. So coefficient for alpha is x, coefficient for beta is 1. B is equal to, similar to previous time, B is equal to y prime. And A backslash B are basically, A backslash B is basically my alpha and beta now. My new alpha and beta. Does it make sense? Now if I plot this line this time, do I need to change x values? I want to plot the new line between -1 and 5. Do I need to change x values? No, x values are the same. Do I need to change y values? Absolutely. Because now I have a new line. Those y values are coming from the new line. So x from before, y is equal to, in this case, remember we had 0.5 times x, or 0.5 times x plus 0.5. Now we have 1 times x instead of plus 0.5, you have negative 1, negative 0.166,7. Now I can plot this line. Plot x, comma, y. Let's do, which color should I use? Green dashed line. See, we fitted a line that has minimum distance to all 3 points. So the method to do this is the same. You again create your A, you again create your B, but A backslash B will give you coefficients that minimize the difference between what's predicted and what was given. Is it more or less clear so far? Yeah? Everyone is good? Now we want to find the residuals. Residual, yes.
This is kind of a step back, but A backslash B, is that giving you your root again? Or what is that? What is A backslash B?
A backslash B is computing alpha and beta.
Okay.
So it's minimizing the distance between what's predicted and what was given. It's minimizing this distance and giving you, so basically changing alpha and beta until this distance is minimized.
Okay.
So that's basically tuning alpha and beta. Now if I ask you to calculate residual for this, do you think your residual is going to be 0 or not? The residual is not 0. Why don't you take a few minutes to calculate the residuals? How many residual values do you have? You have 2 residual values. So between each asterisk and associated y value, there is a residual. Why don't you calculate a vector of residuals for me? So in order to calculate residual, you want to know what is y at this line where x is equal to 1. So at the given x, what is this y prediction giving you, and what is your asterisk, or what was given already? At y equal 2, what is your line giving you, and what is, yes, at y equal 3, what is your line giving you, and what is your asterisk? So your line is basically this one, right? This is your line. Residual is equal to your line minus y. Can someone tell me if this is okay or not? This is not okay, because x is 100 values. We want to evaluate our line at the same x values for which we have y. So the same x value is x. So my line minus what was given to me is basically this vector of residuals. Now, we want to know how good is my fit to this state. I fitted the line to the state. I need to know how good my fit is. There are several matrices that you could use to evaluate the goodness of fit to your data. And all of them use the vector of residuals. One matrix is root mean squared error. Root mean squared error. That is root mean residual to the power of root mean squared error. So you raise each residual to the power of 2. You take the average of all, and then you take the square root. You raise it to the power of 2. Now you square it back. You take the square root and take it back to the same scale. So root mean square error is one matrix. Can someone tell me what's the best value for root mean square error? I have a 1. Any other guess? What is the best case scenario when you fit a line into a bunch of points? In terms of residuals. If you have a residual of 0, that's the best case scenario. I'm going through all the points. So best fit if I go through all the points. So if my residuals are 0, mean of residuals 0, square root of 0, 0. So best value for RMSE is 0. What is the range of RMSE? Can RMSE be negative? No, square root cannot be negative. Can it be positive? It should. Is there a maximum for this? You can have a really bad fit. It can go all the way to infinity. So it starts at 0, goes all the way to infinity. That's RMSE. Now the issue with RMSE is it is dependent on scale. What does it mean? It means that if you have 1.53, you probably have a lower RMSE than if you had 10, 15, and 30. Does that make sense? If you have 10, 15, and 30, and if your difference between 10 and 9 is, difference between 10 and 9 is 1, right? Difference between 1 and 0.9 is 0.1. Relative difference is the same because 1 out of 10 and 0.1 out of 1 have the same meaning, but the absolute values are very different. And that impacts root mean square error. Root mean square error is dependent on the scale of your data. In order to decouple RMSE from the scale of the data, you can use R squared. And I want to write it up here so everyone can see this. R squared is 1 minus sum of all the residuals squared divided by sum of y minus mean of y squared. So what we are doing here is you are raising residuals to the power of 2, taking the average or taking the summation of all, and also we are taking the summation of y minus mean of y. So we are dividing the residual values by the y values. We are removing the scale. If you have 1, we are dividing by 1. So if you have a difference of 0.1 over 1, that's 10%. If you have a difference of 1 over 10, that's also 10%. So basically, we are removing the scale by using R squared. By using this y minus mean of y squared, we are removing the scale of the data. We are normalizing the data. These two equations are super important. If you want to take a note, please do, because we are going to deal with this too over and over. Root mean square error is easy. Root mean square error. R squared is 1 minus sum of residuals squared divided by sum of y minus mean of y squared. First of all, is this y your observation or your prediction? Is y observation or prediction? Observation. Because y pred is prediction. Y is observation. So y minus mean of y. Observation minus average of observation. Residual is y minus. Residual is always y minus y pred. Always. So if I ask you to calculate R squared and RMSE for these residuals, well, before doing that, what is the best value for R squared? What? Now that's 1, right? Because if residual is 0, 1 minus 0 is 1. What is the range for R squared? What if my residuals are infinity? infinity, you have 1 minus infinity, you have negative infinity. Right? So it goes from 1 to negative infinity. Best value is 1. Now calculate R squared and RMSE for these residuals that we found in our previous example. What is RMSE, Joe? You don't want to share? Prefer not to? Okay. Anyone calculated RMSE and prefers to share? Do you have the residuals? Then what is stopping you from calculating RMSE? I don't know. We will calculate it together. RMSE is root. So SQRT, mean squared error, residual dot to the power of 2. You need that dot, right? Root, SQRT, mean, average, residual to the power of 2. Root mean squared error. That's 0.237, 357, yes.
So I thought you were saying an RMSE is equal to a matrix, so that's just a scalar. Or what is RMSE equal?
RMSE is one value, it's a scalar. Because we are, you know, look at this. Residual is a vector. You raise the vector to the power of 2. So you have a vector of values that are raised to the power of 2. You take the average of that vector. That will be one value. You take the square root of that one value. It's going to be another value. So is RMSE clear so far? Now let's calculate R squared. Yeah, so that y minus mean of y should be in Francis. Yeah, so that entire thing should be in Francis. And yeah, so y minus mean of y to the vector. Francis. I think you have an extra. So see what happens here is you have a Francis over. You can use that as an eraser. We have a Francis over here. Minus y minus mean of y to the power of 2. Y minus mean of y is within parentheses, and that's dot to the power of 2. And residual dot to the power of 2. R squared, I call it R2, is 1 minus sum of residuals dot to the power of 2 divided by sum of y minus mean of y dot to the power of 2. It working? Still not working? Good. Yeah, well, no, that's not gonna work. And yeah, and you know, just you see how many mistakes I make when I'm writing my codes. Because that's how it works. I don't wanna remember everything, and I don't wanna track all my parameters. That's gonna blow my mind if I do that. Right? So I'm gonna evaluate it, and then I'm gonna look at it, see if it's working or not. And we did this course at UC Irvine, University of California, Irvine. A professor was going on, you know, calculating everything, and students were looking at it. Not gonna work either. So this is the setting that I like. I like the students to be able to try it and see it. And the reason that we have that first half of class, try and try and try, because you know when people get in, they think that what's going on here, they know it. We need to remind them that you don't know it. And doesn't mean that you'll not get it. It means that you don't know it now. You got to practice, practice, practice until you get it. All right. So that sounds good. Now I'm going to give you an example, and I'm going to let you calculate the coefficients for that example, plot, and calculate R squared and RMSE. Clear CLC. In this case, I'm going to erase this. Is that fine? In this case, you have a pump that has this curve. H, which is pressure, is C1 Q squared plus C2 Q plus C3. Pressure is a function of flow. Pressure is a function of flow. We have observed several pressures, several flows, and we want to find this C1, C2, C3 coefficients. Q and H. 1e negative 4, 8e negative 4, 1.4 e negative 3, and 0.8 e negative 3 are what's observed for Q. 118, 110, 92, and 85 are what is observed for H. Now, given these Q, flow, and H pressure values, we want to find C1, C2, and C3, and then we want to plot. We want to plot this curve between 1e negative 4 and 0.8 e negative 3. So we want to plot this. We want to have the points on it and we want RMSE and R squared. So in this case, your x values are what? Q is your x values. And H is your y value. So instead of y and y prime, you have H and H prime. Your alpha and beta are C1, C2, C3. Now with this, calculate or estimate C1, C2, C3, calculate residual, find RMSE, find R squared, and plot this. Let me also take this time to those are the Q and H values if you can't read them from the screens or from the board. Yeah. Yes. That E is 10 to the power of negative 4. So 1 E negative 4 is 10 to the power of negative 4.
Right.
8 E negative 4 is 8 times 10 to the power of negative 4, which is 0.0000.
So it's like the multiplication times 10 separate, you get rid of
Yes.
0.75 each.
Yeah. Yes. No, that's because your previous one is
Oh, okay.
so that sometimes it gets confused with it. A question? I wasn't sure if that's a question. Yes. Yeah, but this should be commented out. This is like your original equation. You don't want to write it as that. Yes. That's just to start with. That's just the equation. You'll get to this one. That's too soon.
That's one of these ones. So we're supposed to be like,
Yeah, so you did think that should be, let's have interest.
that's just what we do.
So you got
First one is always,
this is all the
X value,
then you have this one,
always,
which should be between
it's equal. your equation is not different. It's not 1 times q cubed, right? It's whatever is here, which is, it's a little difficult because you have 10 to the power of 7 times
You would say,
So why don't you do here instead of a backslash b, put c equal to a backslash b.
we should ask them.
Then this is your c1, this is your c2, this is your c3. Here you will have c1 times qq squared. c1, c of 1. C passes 1. So that's the first element of c, right? Plus c of qq squared dot squared. That is c1 times qq dot to the power of 2 plus c of 2 now times qq plus c of 3.
I'll just say first.
C of 3. Because that's not 0, that's something times 10 to the power of 7.
Right.
Now you can plot all this, and then for the residuals, you have the same thing. Instead of qq, you have q. Okay?
Maybe all this.
Instead of qq, that's a q. For the residual, you know, put it in brackets.
But it's still be minus h.
Minus h, yeah. H is fine. H is the important part.
I don't think so.
So you have about 7 minutes. Let me solve this. You'll have the video. Watch this at home. So A. What's the coefficient for C1? That's a q squared, right? Q prime dot squared. What's the coefficient for C2? That's a q prime. And then I have ones of lengths of q comma 1. So that's my A. My B is equal to h prime. Is that okay so far? My A backslash B is this weird values. You have a 10 to the power of 7 times this. It's just hard. It's 10 to the power of 7 times each of them. It's just hard to get this value. What you can do is you can say C is equal to A backslash B. In this case, C of 1 is your first coefficient. C of 2 is your second coefficient, and C of 3 is your third coefficient. What could be confusing, Nicole?
Oh, I see it.
So instead of just manually getting C1, C2, C3, I put C equal to A backslash B. In that case, the first element in C is my C1, the second element is C2, and the third element is C3. Now, if I want to plot this, I would do QQ is equal to linspace 1e negative 4, comma, 0.8 e negative 3. And then HH is now C of 1, first element in C, times QQ dot squared, plus C of 2 times QQ plus C of 3. Let me put space in between them. So now if I want to plot it, plot Q comma H with red asterisks. And if you want to define marker size, feel free to do so. If you don't want it, just don't define anything, and then you're going to be fine. Marker size of 15, and then hold on, plot QQ versus HH. Well, I have to remove the previous plot. That is why is it not going all the way to the end? Oh, because the maximum value is 1.4 e negative 3. I made a mistake here. So my linear space should be, instead of 0.8, should be 1.4 e negative 3. Was that mine or? Okay. All right, sounds good. So this is my plot now. These are the lines that create that plot. Now I want to calculate residual R squared and RMSE. Residual is basically my function minus h. The only thing is it's not QQ here, that's Q. Because at the same elements that we have h, we need to evaluate our function. So that's my residuals. RMSE is SKURT mean residual squared. So that's my RMSE, 8.8. And R squared is 1 minus sum of residual squared divided by sum of y minus mean of, or h minus mean of h squared. Does it make sense why I didn't use y and I used h? So our squared value is 0.55. Closer to 1, better. Farther away from 1, worse. A rule of thumb is if your R squared is negative, don't use that one. If R squared is negative, mean of your data is a better predictor than your model. So R squared of negative means that that model, whatever it is, C1Q squared plus C2Q plus C3, that works. If R squared is negative. All right, I'm going to stop here. I've already uploaded homeworks for this chapter. We'll go over the homeworks on Friday. There's still some other topics that we should cover, but we'll talk about them on Friday as well. So we have a bunch of absentees today. Thank you.